Hello, my name is Jaime Aguilar. I am a platform architect at Pivotal, and what I'm going to do today is show you a demo on how to deploy Kubernetes with Bosh. Bosh is an open source tool that comprises automation, configuration management, release engineering, and essentially full lifecycle management of distributed systems. So what I'm going to do today is use Bosh to provision all necessary infrastructure resources that are required to deploy a Kubernetes cluster. Once those resources are ready, Bosh is going to install Kubernetes on them and then bootstrap the cluster so that I can use it. For Bosh, everything that you deploy needs to be packaged as a Bosh release. And so what we are going to use today is the Cloud Foundry Container Runtime Bosh release, which essentially is a Bosh release of Kubernetes. So to deploy this Kubernetes cluster, I'm going to use a vSphere environment. I have previously deployed Bosh here so that we can go ahead and just focus on the deployment of Kubernetes. And what we see here is the existing VM, the existing instance with the Bosh director running there. So what I need to do first is to confirm that I can connect to that Bosh director. To do that, and for this and other commands moving forward, I'm going to use the Bosh CLI. So let's confirm I have this environment ready and I have connectivity to it. I do. So the next thing I'm going to do is to just go ahead and deploy Kubernetes using this CFCR Bosh release. To do that, I need to use a manifest. And a manifest is basically my way of telling Bosh, these are the releases that you need to use. So this is the software I need you to deploy. These are the images that I want you to use in order to create these instances, and for that we're going to reference some stem cells, which are the Bosh images, the Bosh-based images, and then I'm going to provide additional properties and configuration to tell Bosh exactly what's the size and shape of that cluster. So essentially things like how many worker nodes do I have to deploy. So I'm going to run a simple command such as this. CFCR-09 YAML is a manifest that contains this CFCR release, and specifically the version 09 of it. That's going to be important later on when we play with the upgrades of the cluster. So I'm just going to hit enter, and that's going to kick the deployment. This is the confirmation that all the changes in the manifest need to be applied, and they are, because it's a new deployment and new manifest. So we're going to go ahead. And from this moment on, Bosh is doing a bunch of things. It's validating the deployment manifest is correct. It's going to check if there's new versions it needs to compile, and more importantly, it's going to create all the infrastructure resources that are required for this. Since this is a new deployment, it needs to create all these missing instances, all these missing VMs. In this manifest, I essentially told Bosh that I wanted a cluster with the master node, which has the Kubernetes API, the scheduler, and also the etcd, and 3 worker nodes. So as Bosh goes ahead with the deployment of these instances, we can also observe if these instances are created in my base center console. So I'm going to refresh here. We should see things already coming up. So we see we have Bosh, and now we have 1 master and 3 workers. So on the Bosh side of things, that's right, we confirm that the VMs have been created. And what it needs to happen now is Bosh needs to deploy and install all necessary software, all necessary processes that we need in order to run Kubernetes. So in the master, we'll go ahead and we will deploy the API server, the etcd, the Kubernetes controller, the scheduler, and on the worker nodes you will deploy kubelet, Docker engine, and kubeproxy. And so after all this software, all these jobs have been deployed, there's also a part where Bosh will trigger the start of the processes that need to be running. And that's a very important part, because what Bosh is going to do is not just create all these resources and start the processes, it's also going to monitor those processes and those resources from this moment on. So in order to do that, on each one of these instances, on each one of these VMs, is deploying an agent, and this monitored agent is going to be in charge on each VM to make sure that all these processes are running. So Bosh has finished with the deployment of the cluster. All the VMs that needed to be provisioned are available, apparently, and all the jobs that needed to be updated in those instances, in those VMs, are also finished. So let's go and check that everything is in place by running this command. We could run Bosh VMs or Bosh instances to get a glimpse of all the instances and VMs that are running for a specific deployment. So in this case, Bosh is returning to us information pertaining to the CFCR deployment, which is the one I created, and we have one master node and 3 worker nodes up and running. We can contrast this information with the vCenter cluster, with the vCenter user interface, and here we have the 3 worker nodes and the master, and obviously via vCenter we can also see the Bosh VM. So now that we have this up and running, I can check and try to access the cluster. So for that, I need the credentials and the kubeconfig. Credentials and certificate in Bosh are stored in CredHub, which is a component that runs inside the Bosh director, and it's pretty much a data store for all secrets and certificates. So the first thing that I need to do is actually log into CredHub. So I'm going to run a quick script to make sure that I'm logged in. And then I'm going to run another script that is going to get those credentials from CredHub and create a cluster and context for the kubeconfig. This is very basic script that just gets that information from CredHub, and as we can see here, creates that cluster and the context that sets to the active context. So if I run now kubectl cluster info, I should see that the API is running and returning information, and if I just run kubectl get all, I should see, in this case, the Kubernetes API service because I'm not in kube system. But if I run -n kube system, I should see all the information that is deployed in that other namespace. So we have essentially a Kubernetes cluster deployed and accessible by us. So now that we have one Kubernetes cluster up and running and accessible, we're going to go ahead and deploy an application. We're going to use the guestbook application that uses a front-end tier of 3 replicas and a Redis master data store in the backend. This Redis master is going to use a persistent volume that is going to be dynamically created thanks to a persistent volume claim and storage class that we're going to deploy alongside with the rest of the resources. And to simplify things, we're going to use just one manifest. So I'm going to just run kubectl create guestbook all in one for vSphere. Now before I run that, let me run this command just so that we can see everything that is happening in real time when I create all the resources. So we can see that we have storage class, persistent volume claim, and the persistent volume dynamically created. And we have all the services that are required by the deployment, plus the 3 pods for the front-end tier and 1 pod for the Redis master. So now that we have everything up and running and ready, we are going to do a simple access to the front-end application. Since I have access to the network where these VMs are running, I'm going to ask Bosh again to give me the list of VMs. I could do this obviously from the vCenter console as well. So I'm just going to use one of the worker nodes because I know that my front-end tier is running on every single worker. We have 1 pod per worker. So I'm going to just point to this node and use the node port that we have in the service. So the port is 32059. have the guest web application. Let's write a couple of messages. Seems to be working fine. Now, obviously, I have accessed this in this very quick way. In a real-world example, you likely will have other means to drive traffic into the workers. You have an external IP or a load balancer or an ingress. But for the purpose of the demo, this was the fastest route.